Welcome students in our series of lectures on microprocessor 8085, and we are discussing the pin configuration of microprocessor 8085. And in this process, we have discussed the IO/YAMBAR pin in the last lecture. Today, we are expected to go forward, and we will be discussing pin number 32. And the 32 number pin is it stands for RDBar. I have told you that whenever a bar is present at any pin, at the name of any pin, it means that that particular pin is active low. Active low means whenever the potential at that point goes to zero value, then it comes into active region. So I will read out first of all the necessary things about this RDBar pin. RD stands for read. So READ. So EA we have dropped, and RD. So RD stands for read. It is an active low signal. I have told you that whenever there is a bar, the signal is active low. It is a control signal used for read operation either from memory or from input device. Remember, whenever we use the term read, it means that microprocessor is reading the data from somewhere. Now, from where the microprocessor can read the data? Microprocessor can read the data either from a memory location or from input device. Okay, so from either from memory location or from input device, whenever microprocessor is reading the data. Reading means getting the data. Reading means inputted. The data is inputted. Okay, so whenever microprocessor wants to have the data either from memory or from input device, the pin the voltage of pin 32, that is RDBar, goes low. The low signal indicates that data on the data bus must be placed either from selected memory location or from input device. When the pin voltage of 32 goes low, the data from either from memory location or from the input device is loaded onto the data bus. The data bus is from 12 number pin to 19 number pin. Data in the case of microprocessor 8085 is of 8-bit only. Okay, so RDBar pin stands for the receiving the data from either memory or input device. Similarly, the pin number 32, I will highlight that pin. I will try to highlight this. Okay, so this is the pin number 31. 31 number pin is WRBar. Again, this is the active low pin. It means that whenever the voltage of the pin number 31 goes low, the WR pin will go into active. So WR stands for write, means microprocessor will write. Remember, microprocessor will write means microprocessor will output the data, output the result either to the memory location or to the output device. Okay, so it is also active low signal. It is a control signal used for write operation either into memory or into output device. Okay, so whenever microprocessor has something, has certain data, has certain result, and if microprocessor wants to store, wants to share that data, wants to share that result either to a memory location or to the output device, the pin number 31 goes low, means the voltage at pin number 31 goes low, and definitely then the data is transferred from microprocessor to the output device or to the memory. A low signal indicates that data on the data bus must be written into selected memory location or input output device. It is very easy to understand. See, once you understand the concept of 8085, because 8085 works as a brain of a human being, so you have to understand how it works, how it relates its operation to the peripheral devices, how it shares its operation. So reading means getting the data, writing means giving the data. So these concepts are important. Once these concepts are clear, then it will be very easy for you to understand the different functioning of the microprocessor 8085. Now we will shift our attention to pin number 35, which is used as ready pin. This pin is used to synchronize slower peripheral devices with fast microprocessor. A low value causes the microprocessor to enter into wait state. The microprocessor remains in the wait state until the input at this pin goes high. Remember, whenever microprocessor receives the signal from this ready input, because look at the direction of the arrow. This pin is used to synchronize slower peripheral devices. There are number of peripheral devices connected to the microprocessor 8085. Those peripheral devices may be input device, maybe output device, maybe certain kind of memory. So all these devices, the peripheral ICs, peripheral devices, they are connected to the microprocessor. But remember, microprocessor, the speed of the microprocessor, we have discussed that it is nearly about 3 megahertz. So it works on that fast clock of 3 megahertz clock. But the peripheral devices, they are not able to work so with higher speed, with the speed matching to the microprocessor 8085. So there is a difference in the speed. Now, whenever the external device or the peripheral device wants to communicate with the microprocessor, then the speed of the microprocessor is high, the speed of the peripheral device is low. So there must be certain synchronization. So whenever the data or the certain important needing concept is to be transferred from peripheral device into the microprocessor, the ready pin goes low. And when it goes low, microprocessor remains in the wait state until the input at this pin goes high. So it is active high pin, and it is used by the other devices to indicate the microprocessor that certain data transfer is going to happen, and microprocessor is needed to wait for some time. So this is the function of ready pin. Now we will go for the next pin, pin number 38, that is hold. Pin number 38. Hold pin is used to request the microprocessor for DMA transfer. So DMA is another concept in the data transfer schemes which are used by microprocessor 8085. DMA stands for direct memory access. The detailed concept of direct memory access we will discuss in due course, but here you have to remember only that hold pin is used in the DMA data transfer of data, means when the data is transferred directly from memory location to the output device, or from input device to the memory location. High signal on this pin is a request to microprocessor to relinquish the hold, or the hold on buses. Remember, whenever data is to be transferred from microprocessor to the input device to the memory location, we have to use the data bus as well as the address bus. But for the transfer of bulk amount of data, whenever the bulk amount of data is to be transferred, these two buses are used by a certain DMA controller. There is different IC which will control this transfer of data. So DMA controller controls the performance, controls the transfer of data. Whenever DMA controller controls the transfer of data, the microprocessor relinquish. This is the new word for you. So this is the signal which is hold, and we are discussing this signal, and this is the new word, relinquish. Relinquish means breaking the connection. Now, whenever microprocessor relinquishes the data and address bus, then it has no control over the data bus and address bus. Here, microprocessor 8085 do not put address on the address bus, do not receive the data which is available on the data bus. But both these buses are controlled by some DMA controller. This request is sent by the DMA controller that I have explained. Whenever we will discuss DIM-A data transfer scheme, at that moment I will be explaining in detail the hold pin for you. Okay, so we will go to the next HLDA, hold acknowledge. This is the pin number 39, probably the last pin which we will be discussing. HLDA means hold acknowledge. Once the request of hold is received by the microprocessor, microprocessor relinquishes the address bus and data bus, and make those two buses available for the DMA controller. And when this particular function is complete, then microprocessor sends hold acknowledgement. Acknowledgement means it's a receipt that I have received the hold signal from you. requesting that my internal functioning should be stopped for some time, and I am now making available my address bus and data bus for your control. So it is acknowledgement given to the DMA controller. The microprocessor uses this pin to acknowledge the receipt of hold signal. When HLDA signal goes high, address bus, data bus, RD, WR, IO, MBAR pins are tri-stated. Tri-stated means they goes into high impedance state. Means they are neither on, they are not off. They goes into the third state, important state, that is called as this tri-stated. This means they are cut off from the external environment. They are not connected actually. Means high impedance is provided there, and in this way the HLDA signal acts. And we have discussed, I think, the last pin. Okay, so these two pins, I think we have discussed about 20 number pin. So power supply is connected in between pin number 20 and pin number 40. So we have completed discussing 40 pins of Intel 8085. Okay, now as I have told you, you must be able to understand the functioning of each and every pin of 8085 so as to understand the internal structure of 8085, how 8085 interacts with the peripheral devices, how 8085 interacts with memory, how 8085 performs DMA operation, how 8085 can give the data to the outer world, can receive the data from the outer world, how it is interrupted. There are interrupt pins from trap, RST 7.5, RST 6.5, RST 5.5, and all INTR and INTA bar. So number of pins means 40 pins, 40 number of pins are available, and they perform different operations. Each and every operation must be clearly understood by the student and by the user of microprocessor 8085. Thereby, he will be able to understand the functioning, he will be able to perform programming with the microprocessor 8085. So, at this moment, we have finished the 40 pins of 8085. Let us stop here, and in the next lecture, we will be going with the architecture of microprocessor 8085. As always, I will remain very thankful for you. Okay, so thank you, and please watch this video up to thank you and give your remarks. Thank you very much.